Friday. Okay. Okay, so example 2. Just gonna do the same thing. Plug those into desmos. Figure out where they cross. Let's erase this junk here. So x squared, so you should see the little square button down there where it says a squared, so x squared equals 2y plus 10. There's our parabola. And then 3x minus y equals 9. There's our line. So it may appear, and this is not too bad, you can see that there is a gap, right around where it says x is 3, there's a little gap there, right? So they're not actually touching. There's only 2 places where they actually are touching, which is up here, and then down here, the only places they are actually touching. In between there, some space, very small space, but space. So I'm going to graph the line first, since that's going to be the easier of the 2 things to graph. So I'm just tapping on the black line there. I can see that its y-intercept is way down here at -9. Looks like its x-intercept is there at 3. So I'm going to graph between those 2 points, 3 and -9, to draw that line. -3 and -9. So it's a line. I'm going to use a straight edge to do that. Too zoomed in. All right. Now, obviously, the other one was a parabola. I want to need more than 2 points to draw a parabola. Again, you're having to calculate any of the points or anything like that. And you guys don't need to make a table, but you are trying to emphasize what's happening here. So just when I see that, if I just click on the line, it pops up 5 points there pretty quickly for me, and grab those x-intercepts, which are just on the outside of the 3's. So I'll just eyeball that. See my vertex down there, 0, -5. Of course, that's an important point. Then I can use these 2 intersection points to help kind of guide me. So I just had written these down earlier just so I don't have to flip back and forth on you guys. But obviously, if you guys have 2 screens right next to each other, or your screen and then your paper there, it's pretty easy to just kind of copy those points over. So I'm just going to plot those points and then just do my best to draw that curve there. Since it is a curve, I just need more information. So, and you guys don't need to find ways to generate a bunch of points. Just use what's kind of being given to you by desmos. On the outsides of the 3's, got my x-intercepts. The y-intercept was down here at -5. 4, 3 is one of the points where they cross. At 2, -3 was the other point where they cross. So I'm just going to do my best to draw a parabola through those 5 points. And these 2 points here are the most important. That's where the line and the parabola are supposed to cross. Do my best. Not expecting magic here by any means. Let's see what happens now. Dang, look at that go. That's good. But why we're here is to grab that 2, -3, and that 4, 3. Where do they cross? So we have 2 points of intersection for 2 equations, so we're going to have to do 4 checks. And make sure that both of those points work in both equations. Should be pretty simple though. And start doing some of that in your head, right? Just be really careful getting the numbers in the right spots. It says x squared, so what's your x value? It's 4, so what's 4 squared? That's 16. So 16 equals 2 times 3, which is, y. So 2 times 3 is 6. So 6 plus 10, or 16 is equal to 16. Check. Doesn't work in the other equation. 3 times x. X was 4, so 12 minus y, which is 3. 12 minus 3 is supposed to be 9. 9 is 9. Okay. 4, 3 works. I'll check to negative 3. X squared. X is 2. 2 squared is 4. 2 times y, which is negative 3, so 2 times negative 3 is negative 6. Negative 6 plus 10. Negative 6 plus 10 is 4. 4 equals 4. And 3 times x, which is 2, so 6 minus negative 3 is supposed to be 9. 6 minus negative 3 is 6 plus 3. Of course, 9 equals 9. So you guys just kind of mess around. Again, the main thing, guys, is just like seeing how the different graphs interact. Just checking your arithmetic. Okay. This should be a pretty low stress assignment. Guys feeling okay? Got a thumbs up from Aiden. You all right, Jarrett? June? You all right? All right, last one. Got a line here. It's a horizontal line. We've been doing those lately. Y equals, that's a horizontal line. And then we got that exponent, that's a variable, that's an exponential function. It's going to have a horizontal asymptote. That steep curve, when we go to draw it, we'll see it, that steep curve. Okay? Just recognizing it for what it is even before we graph it. There it is. Let's go ahead and graph it though. So y equals, so 2 to the x, so 2. So down there on the left keyboard thing, you see the a to the b. Okay, so we need to hit that a to the b button. That'll give me that blank exponent spot, and then I can put my x in there. I'm a little surprised you can just actually hit -6 and it pops the -6 down. I'm kind of surprised it does that. Usually it kind of keeps things up in that spot, but whatever. Just hit -6 after that. And then y equals -5 next. So we definitely see they do cross. But there we see that exponential curve, and there's that asymptote down there at -6. It's supposed to be at 0, but that push 6 down. So I'm going to go ahead and sketch in the asymptote just because that's what we do when we draw exponential curves. So I'm going to draw the green one first here, but that has an asymptote at -6. And I'm going to go back and look at that curve a little bit more. So I need some points on it. I'm just going to grab the y-intercept and the x-intercept and hope for the best after that. So 2.5 and then -5. X-intercept is 2.5, y-intercept is -5. I know that just the general shape of the curve, steep curve up on the right side, and it should kind of flatten out on the left side. So I'm just going to do a better job of drawing that about shape there. The other one's just a horizontal line through -5. Not much easier to draw than that. Of course, their intersection point here at 0, -5. So checking 0, -5. Be all done here. So y equals, all right, so starting off with my y values, that's -5, equals 2 to the 0 minus 6, 2 to the 0, 1. Anything to 0 power is 1. So 1 minus 6 is -5, which equals -5. And the second one's kind of weird, right? It says y equals -5, right? Well, what do I do with my x? There's no x. Huh? You don't do anything with your x. There's no x to put it in. It's all you have to worry about is what y is. So y is -5. So -5 equals, or that's wrong color. -5 equals -5. Well, that was easy to check. Right, our y value is -5. Yeah. So first of all, boom. Okay. So that's it for the notes. Just a couple of little tips on the homework. Somebody in first hour noticed that the graph got too big. Like it was essentially the same thing that was happening here, just that the second point of intersection was up above 10. Okay, so wouldn't fit on the graph. So if the graph it just gets too tall, just count by 2s instead. All right, so don't be afraid to rescale this if you need to. So yeah, so just watch out for that. If a line touches a parabola, and if it goes like inside the parabola, it's going to have to come back out. It can't go in and then stay in for the rest. It's going to come back out. So if it touches once like this, it's going to have to touch like on its way back out. And it can like kind of like kiss across to the bottom of it or something like that, but it does never go in, so then it won't have to come out. So if you see it go in, it will have to come out. So just kind of you knew to kind of like scale, zoom out to see where it crossed. So yeah, so if it does seem like it's going off the graph, then just rescale your graph when you're sketching it. The other thing, on the back side of the worksheet, there's a log base 3 problem. So how do you type that into this? So when you need to type a log in, you go to the functions button that's down there on the right. Okay, so hit functions, and then all the way on the right side where it says miscellaneous. Okay, if you look at the left side, you see the natural log and the log buttons. But that's natural log and that's log base 10. In the middle column, you see the log base A button. So right there in the middle, almost at the bottom. So when you type that log base A button, and then you see the little cursor down there, it's like waiting for you to tell you which base to use. So then you can type in the log base 3 that it wants. Okay, so that's how you find the log base whatevers. Okay, so that was the only other kind of weird thing on the homework. Just watch out for the scaling. If it seems like it's going to pop off the graph, then just change your scaling on your graph. I think there's a couple that I've seen that look like that. Like number 3 also gets too big for the graph. But just count by 2s then, should be fine. But everything else should be pretty straightforward.